Hey friends, my name is Aamish and uh, today's video is about writing empirical formulas, and I'll tell you how to write empirical formulas and what empirical formulas mean and how to convert molecular formulas into empirical formulas. Okay, so let's begin. So basically the first thing that we need to know is that what does empirical formula basically mean. So empirical formula is a formula that gives the simplest whole number ratio of the different atoms in a compound. So you'll have a chemical formula, and there you have like different atoms of like different elements in a compound, right? Different atoms in a compound. For example, CHO. And then empirical formula would be the simplest whole number ratio. Okay. So the example over here is H2O2. It's basic. H2O2 is hydrogen peroxide. So H2O2 is the molecular formula, which is like the full formula, as we say. So H2O2 is the molecular formula of hydrogen peroxide. However, HO is the empirical formula of hydrogen peroxide. How we got HO? We basically simplified the whole number ratios. So uh, H2O2, both of these twos are divisible by 2. Like 2 is the highest common factor between them, so you divide these twos by 2, and then you get 2 divided by 2 is 1 and 2 divided by 2 is 1, so you get HO as the empirical formula of hydrogen peroxide. A quick tip is that think of the numbers like these numbers in front of the elements. Think of the numbers as fractions as we simplify them in the same way. That is using the highest common factor. So think of these numbers as like fractions, okay? And because we have to reduce them or simplify them in the same way. So to write the empirical formula, we must get the numbers to their most reduced or simplest form. Reduced and simplest is the same thing. So we have to basically simplify the numbers as much as possible, okay? So I'll give you some examples now. Here we have a, like, you can say not quite a table, but a comparison between molecular and empirical formula. So the first thing that you need to ask yourself is that when you're writing an empirical formula, you should ask yourself what's the biggest number that we can divide the numbers. Then by numbers I mean the numbers in front of the element. So in this case C4H10, 4 and 10 are the numbers. So what's the biggest number that we can divide the numbers by in the molecular formula to get them as reduced as possible. By reduced I mean simplified, okay? As much simplified as possible. So we have the molecular formula C4H10. So what's the highest factor of 4 and 10? You basically divide them by 2. Why do you divide by them? Why do you divide them by 2? Because 2 is the highest number uh, that these two numbers will be divisible by. Okay, so you divide 4 by 2 and you divide 10 by 2. 4 divided by 2 is 2, 10 divided by 2 is 5. So the empirical formula, oops, sorry, just a second. So the empirical formula would be C2H5, because you divided 4 by 2, which is 2, so C2. Then you divided 10 by 2, which is 5, so H5. So C2H5 is the empirical formula. We cannot divide 2 and 5 by the same number anymore, so it's in the simplest form. You cannot divide 2 and 5, they do not have a common factor now. So this means that it's in the most reduced or most simplified form. So this is called the empirical formula, okay? Another example is C3H6. The highest number that you can divide 3 and 6 is 3. Okay, so you divide 3 by 3 and then you divide 6 by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. So when you divide these, 3 divided by 3 is 1, so you get C. There's no number in front of C, that means that it's C1, but you do not write 1, you just leave it blank. So it's C and H2, because 6 divided by 3 is 2, so C H2. We cannot divide 1 and 2 by the same number anymore, so it's in the simplest form. So this is basically the empirical formula, okay? Now I'll give you some more examples. And yeah, a key thing is that keep practicing. Like watching videos or reading books won't be of great help to you if you are not practicing. uh, you should practice on paper. You should do it, do the thing, and you shall have the power, okay? So now I'll give you some more examples. So here we have molecular formula C8H6O4. So again, ask yourself the question, what's the biggest number we can divide all the three numbers, which are 8, 6, and 4. So what's the highest factor between 8, 6, and 4? So the highest factor is 2. We can divide all these three numbers by 2 to reduce them into their simplest forms. Okay. The molecular formula is C8H6O4. So the largest number we can divide 8, 6, and 4 is by 2. So when we divide them by 2, we divide all these three numbers by 2, and when we divide them, we get C4H3O2, because 8 divided by 2 is 4, 6 divided by 2 is 3, 4 divided by 2 is 2. So C4H3O2 is the empirical formula. Okay. Now I'll give you some more example. Again, I'm telling you, do the thing and you shall have the power. Keep practicing. uh, right now, before completing this video, uh, write these down and then solve them on paper. Okay. So these are some more examples of molecular and empirical formulas. So yeah, how do you identify molecular formula? Just in case you want to know. So basically, if the formula have numbers, these numericals, if they're not reduced in their simplest form, if they're not in their simplest forms, that means that the formula is a molecular formula. If it's not, if they are not like in their simplest form. Okay. So here's an example. So the molecular formula is C6N24. The highest number that you can divide both 6 and 24 with is 6. So you divide 6 by 6, which is 1. You divide 24 by 6, which is 4. So the empirical formula becomes the empirical formula becomes CN4, because we divided 6 by 6, which is 1, and when there's 1 you don't write anything, you just leave it with C, and then you write, and then 24 divided by 6 is 4, so we have CN4. Okay. So here's another example, which is SNN9. So this cannot be simplified because it does 7 and 9 do not have a common factor. Okay, so it cannot be simplified. So the molecular and the empirical formula are the same, they're constant, they're the same. We didn't change anything because they cannot be simplified. This formula cannot be simplified. Okay. It does not have a common factor, so it stays the same. Now let's do some more examples. Here are some more examples. So we have the molecular formula called the molecular formula in the first example is H8O8. So what's the highest number that you can divide these two numbers with? It's basically 8. You first divide 8 by 8, which is 1, and then for the 8 with the oxygen you also divide this 8 with 8, so that's also 1. So the empirical formula is HO. Okay, because H, there's only one H and one O, so you do not need to write 1, you just write HO, because we divided both these 8 by 8, which gives us 1. Okay, so just a second. So we divided this with 8. Okay. uh, Now let's see the second example. uh, in the second example we have S10. So S10, how it's like a single element sulfur, and it has 10 sulfurs. Okay, so S10, what do? You just divide 10 by 10, which gives you 1. So 10 divided by 10 is 1, so S10 becomes S. So the empirical formula is S. Okay, now let's see. Because you can just divide 10 by 10, so it becomes you divide 10 by 10, which becomes 1, so it's S. Now this third example is uh, C14H12O. Okay, this number cannot be further simplified, so the molecular and empirical formula stay the same, because you cannot divide these three numbers by any common factor, because oxygen does there's only one oxygen, so that means you cannot simplify. uh, so the molecular and empirical formula are the same. Okay, let's do some more examples. So here in the first example we have the molecular formula F3H3O6. uh, Now what's the highest common factor of 3, 3 and 6? It's basically 3. the highest number that you can divide all these three numbers are with is 3. Okay, so you divide 3 by 3, which is 1. You divide this second 3 with 3, which is 1. You divide this 6 with 3, which is 2. So the empirical formula becomes SHO2. Okay, because you divided all these three numbers by 3. So the second example, we have H2O2. The highest common number that you can divide both these twos is by 2. So you divide these two numbers with 2. So 2 divided by 2 is 1, and 2 divided by 2 is 1. So it becomes HO. Then the third example, we have C15H5O10. Now what's the highest number that you can divide all these three numbers with is by 5. So you divide 15 by 5, which is 3. You divide 5 by 5, which is 1. And you divide 10 by 5, which is 2. So it becomes, the empirical formula becomes C3HO2. Okay, that's how you do it. I'm encouraging you to practice. Do not give up on your studies. Be persistent, persevere, and keep practicing on paper, and eventually you'll get the hang of it. Okay, and then it will become super easy. It's just like any fractions in maths or whatever. So it's super easy. Okay, keep practicing, do the thing. So guys, thanks a lot for watching. I wish you all the best for your exams. Please like, subscribe, click on the bell icon, comment and share my video, and comment below what topic shall I do next in my next video. And I wish you all the best. I love you guys. See you. Bye bye.